and read that again. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. When you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. Okay, so today we're going to start with answering questions from 7.5 and then go on to 7.6. So let's get started. 7.5, simplifying complex fractions. Do you have any questions for me?
No, I didn't have any questions.
Okay.
Neither did I.
Okay. Greg, how about you? Anything? Okay.
No, I didn't have any questions.
Good. All right. We'll go on to 7.6 then. All right. Looks like things are acting weird. Hopefully that's not going to stay. So we've taken a fraction and multiplied the top by the LCD and the bottom by the LCD. So in effect, multiplying by 1. The LCD divided by the LCD is 1. Now we're going to take an equation with fractions and multiply both sides of the equation by the same quantity, that quantity being the least common denominator of all the terms in the equation. What that will do, in effect, is get rid of all the denominators and turn the equation into a fraction-free equation, so to speak. So let's start out with something fairly basic. Oh, goody. It's doing it again today, isn't it? 2/3 equals 1/2 plus x over 6. All right. So the denominators are 3, 2, and 6. What is the LCD?
6.
6, correct. So what we're going to do, we're going to multiply both sides of the equation by 6, okay? Since all the denominators, the 2, the 3, and the 6, are included in the least common denominator, when we distribute and then go back and simplify, reducing each fraction, the denominators will be reduced out. On the left side, 6 times 2/3, the 6 and the 3 could reduce to 2/1, okay, which gives me 4. All right, any questions there?
No.
On the right side, I get 1/2 times 6/1 plus x over 6 times 6/1. When I go back and reduce each of those fractions, 6/2 is 3/1. Let's see, I'm going to stick there. And x over 6 times 6/1, 6/1 is 1/1. So I've got 4 equals 3 plus x. And voila, the fractions are gone. Any questions about what I did or what just happened there?
No.
Okay, so now we have an equation with no fractions. We'll continue. I'm going to subtract 3 from both sides of the equation, and x equals 1. Again, any questions?
No, not for me.
All right, let's take a look at another problem. B over 4 plus 1/2 equals B over 3 minus 1/4. So what is the LCD of 4, 2, 3, and 4?
12.
12, correct. Good job. So now we're going to multiply both sides of the equation by 12, by the LCD. Once again, because 12 includes the 4, the 2, and the 3, it's going to wipe them all out as we distribute and simplify. So I'm going to get 12 over 1 times b over 4 plus 12 over 1 times 1/2 equals b over 3 times 12 over 1 minus 1/4 times 12 over 1. Okay? Any questions? So now I'm going to go back and simplify. 12 over 4 is 3 over 1. 12 over 2 is 6 over 1. 12 over 3 is 4 over 1. And 12 over 4 is 3 over 1. So 3 times b plus 6 equals 4b minus 3. All right with that?
Yes.
Okay, so now I have an equation with no fractions. I'm going to solve for b. I'm going to solve for b on the right side. So I'll subtract 3b from both sides. 6 equals b minus 3. I'll add 3 to both sides, and 9 equals b, or b equals 9. Again, any questions? All right. Four fifths minus 1 over 10x equals 7 over 15. So what is the LCD of 5, 10x, and 15? Be careful.
30x.
Good job, 30x. And the rest of you, if you have any questions about like, where did they get that? Speak up and I'll go through it if you need me to. Otherwise, I'll just continue on. So we're going to multiply both sides of the equation by 30x. I'm going to distribute 30x times 4 fifths minus 30x times 1 over 10x equals 7/15 times 30x. Okay, so now we'll simplify. 30 over 5 is 6 over 1. 30x over 10x is 3 over 1. We got rid of the x there. And 30 over 15 is 2 over 1. So going back, 6x times 4 is 24x minus 3, we got rid of the x's there, equals 7 times 2, 14x. And once again, the fractions are destroyed, wiped out, gone. Okay. I'm going to solve for x on the left side. I'll subtract 14x from both sides. So 10x minus 3 equals 0. I'm going to add 3 to both sides. 10x equals 3. And divide by 10, x equals 3/10. Is this driving you crazy because there's this delay between what I write and say and it shows up? Or is it?
Quite nice.
Okay. Yeah, it drives me. I don't know what happens. Every once in a while it does this. And this morning I didn't have an earlier class because they have a test. And so I should have checked it out to make sure, but I didn't. Oh, well. All right. How about this one? Let's see here. 10 divided by t minus t equals 3. What's the LCD here?
T.
T.
Yeah, you were hesitant because you thought it can't be that simple, right? You were thinking there's something wrong here. No, it's just T. Okay. And I'm just putting those ones under the LCDs just to remind you that they're in the numerator. All right, so distributing T times 10 over T minus T times T equals 3 times T. Let's see, the first term, I'm going to reduce out the T's, and that's pretty much it. So my first term is going to be 10. My second term is going to be minus T squared, and my third term, 3T. The fractions are gone, but I now have a second degree equation. All right, so to solve a second degree equation, we're going to put it in standard form. One side is going to be a trinomial. The other side is going to be 0. I'd like to have my leading coefficient positive. Since this is my highest degree term, I'd like to move that to the other side so that it's got a positive 1 coefficient. So I'm going to add T squared to both sides, and I'm going to subtract 10 from both sides. So that's going to give me 0 equals T squared plus 3T minus 10. Okay. So now on the right side of the equation, I'm going to factor. Let's see, a product of negative 10 and a sum of 3. How about a plus 5 and a minus 2? Okay. So if we have T plus 5 equals 0 and we subtract 5, we get T equals negative 5. And if we have T minus 2 equals 0 and we add 2, we get T equals 2. I guess I could have written this over here. I just didn't know if I was going to have enough room. So T equals negative 5, T equals 2. 2 solutions to that equation. Okay. All right. Let's see. Now I want to look at another equation. 4 minus 8 divided by x plus 1 equals 8x divided by x plus 1. So what is the LCD here?
X plus 1.
Correct. X plus 1. So I'm going to multiply the left side by x plus 1 and the right side by x plus 1. Okay. So distributing, we get x plus 1 times 4 minus x plus 1 times 8 over x plus 1 equals 8x over x plus 1 times x plus 1. And if it makes it clearer, we can put parentheses here instead of just those little dots, just however you want to do it there. Same thing. All right. Let's see. Nothing's going to reduce out of the first product. Of the second product, the x plus 1s will reduce to 1 over 1. And of the third product, the x plus 1s will reduce to 1 over 1. Okay. Again, any questions so far? All right, so now I've got 4x plus 4 minus 8 equals 8x. I'm going to combine like terms on the left side of the equation. 4x minus 4 equals 8x. I'm going to solve for x on the right. So I'll subtract 4x from both sides of the equation. And I'll divide both sides by 4. So I get -1 equals x, or x equals -1. Now, there is something that I should have been doing on all the previous problems, but I deliberately skipped an important step to set up this situation. And that is to check my work, to check my answers. Let's take a look at x equals -1. What happens if I put it right there or right there? What does the denominator become?
Would it be x minus 1? Or would
Well,
do you like putting -1 where the 1 is?
no, you'd put it where the
Oh,
x
wait,
is.
where the x is, I'm sorry.
It would turn into 0, right?
Ah, and so then
Would-
we'd be dividing by 0,
would be
which,
un-
yeah, it's all fun and games till we divide by 0 and then the universe collapses. So basically, there is no solution because the only answer we came up with doesn't work. Now, if we were in an ordinary classroom and I was doing things with you and we weren't using WebAssign, I would say, this is what I'd like you to do. However, this is what the instructions in WebAssign want you to do, all right? You would solve this equation and you would come up with x equals -1. This is what's known as an extraneous solution. Let's see, how do you spell that? E-X-T-R-A-N-E-O-U-S, extraneous. And so basically, I believe WebAssign will say, you know, find solutions, and then it'll say something about are they extraneous. So you're going to say that this is extraneous. Okay. Yeah. And I think I messed people up last quarter because I said, well, it's no solution. They put that in and WebAssign didn't like that. So the solution doesn't work, but here's what we came up with. It doesn't work, so we call it extraneous. All right? Okay.
All right.
All right, there we go. Okay, let's go on. How are we doing for time? We got lots of time left. Okay. Let's see here. X plus 6 over x plus 4 plus 1 over x squared plus x minus 12 equals 1. It says solve each equation and check the result. If an equation has no solution, so indicate. All right. So I need to find the least common denominator. But now things are a little bit trickier because I need to take that second fraction and factor the denominator to help me determine what the least common denominator is. So I'm going to have a +4 and a -3. Okay, so factoring that, I get what's below there. All right. So now, what is the LCD?
Would it be x plus 4 and then parentheses, wait, no, parentheses x plus 4, parentheses x minus 3?
Right. We don't need both of the x plus 4s, right? We just need the highest power within each single fraction. In fact, let's go back here a ways. Oops. For instance, here, even though there were 2 4s, we didn't include 16 as part of it. We just took the highest power of each, right? So you are correct in that we just need an x plus 4, just one of them, and an x minus 3, just one of them. Okay? All right, here we go. So we're going to multiply both sides of the equation by x plus 4 times x minus 3. Oops. I messed up there. Hang on. Okay. Come on, eraser. Don't fail me now. There we go. Okay. So actually, let's see here if I can make this work. I should have put my parentheses here. Okay. Sorry about that. And then over here, x plus 4, x minus 3. So in other words, let me switch colors here. I'm multiplying all of this by x plus 4 times x minus 3 and all of this. Okay? All right. So we're going to distribute. We're going to get x plus 4 times x minus 3 times x plus 6 over x plus 4. And then we're going to take this times this. So we're going to get plus x plus 4 times x minus 3 times 1 over x plus 4 times x minus 3 equals 1 times x plus 4 times x minus 3. So I'm distributing the x plus 4 times x minus 3 to this term and this term and that term. Okay? Any questions?
No.
Right. So now these reduce out to a 1 over 1. These reduce out to a 1 over 1. And the final product, nothing reduces out. So here I have what? X minus 3 times x plus 6, which is going to be x squared plus 6x minus 3x minus 18. And then all of this is going to be just plus 1 equals over here 1 times everything is going to be just the everything, right? So then I could take, in other words, this is going to end up just being that, right? Because the 1 times, so then I'm going to get x squared minus 3x plus 4x minus 12. Okay? Big long mess, but we've gotten rid of all the fractions. Any questions before we go on? All right. On the left side of the equation, combining like terms, I've got x squared plus 3x minus 17. On the right side of the equation, combining like terms, I've got x squared plus x minus 12. Now, this is a second degree equation because our highest powered exponent is 2. Okay, so x squared. So I want to have everything on one side of the equation set equal to 0. Okay, well, I'm going to move everything to the left. So I'm going to start out by subtracting x squared from both sides. But I see that when I do that, it's no longer a second degree equation. It's a first degree equation. So now my thinking changes. Instead of setting it equal to 0, I'm going to just put all the x's on one side and all the constants on the other. Okay? So now I'm going to subtract x from both sides. 2x minus 17 equals negative 12. Add 17 to both sides. 2x equals 5. Divide by 2, and x equals 5 halves. Okay. Now, there's 2 levels of checking your work. Okay. If you are just totally confident, there's no way I'm going to make any mistakes, I don't have to check my work, blah, 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 you still need to plug the answers into all of the denominators, because in the last problem, I didn't do anything wrong. I didn't make any mistakes, but the answer didn't work. Oh, wait a minute. I did make a mistake. I violated a rule. What rule did I violate? Well, and again, we've gone back to the previous problem. When you're solving an equation, you can add or subtract the same quantity to both sides of the equation. You can multiply or divide both sides of the equation by the same non-zero number. In other words, it isn't legal to divide both sides of an equation by 0, and it isn't legal to multiply both sides of an equation by 0. Well, what does that have to do with anything? Well, and again, back in this previous equation, we multiplied everybody by x plus 1. But if x equals -1, what is x plus 1? That's -1 plus 1, which is 0. So I didn't know at the time that I was breaking the rules. I multiplied both sides of the equation by 0. Okay? What is it they say? Ignorance is no excuse of the law. Well, anyway, so I broke the rules. That's why I got an answer. But when I checked it, it didn't work. All right. So what does all that have to do with anything? Okay, now let's go back to the one we just finished. I need to make sure that that does not make any of the fractions dividing by 0. So let's go back and look at the original equation. Let's see. We had this denominator and we had this, which became this. All right, here, if x is -4, we're in trouble. X is not -4, we're fine. Here, if x is -4 or +3, because if it took on either of those values, the denominator would be 0. So we're fine, okay? So this solution should not cause this thing to be undefined, okay? So even though I didn't make any mistakes, I'm saying, I never make mistakes, I better check this at least, okay? Now, if you're not confident, like, well, I want to make sure, then you'd take the 5 halves and you'd plug it in every place it appeared in that original equation, okay? Do you want me to go through that process for this problem?
I'm okay, thank you.
Thank you. I didn't want to. I'm lazy. All right. But I could have. Okay. Now, let's see here. Again, looking at the time, I want to make sure I get through everything. Let's take a look at some formulas. Here we have 2 divided by C plus 2 divided by D equals 1 divided by H. The directions say solve each formula for the specified variable. And for this particular problem, we are to solve for C. Okay? So our approach is going to be the same as before in that we're going to clear the fractions because I need to get C by itself. Now, if you look at the first term, 2 over C, if I somehow got rid of the 2 in the numerator, I still wouldn't have C. I'd have 1 over C. C needs to be up on top. So what I'm going to do, I'm going to multiply both sides by the LCD. And what is that?
CDH.
CDH, correct. CDH. So I'm going to multiply both sides of the equation by CDH. Okay, again, any questions? All right.
No.
So on the left side, distributing CDH times 2 over C plus CDH times 2 over D equals 1 over H times CDH over 1. Okay? Any questions? All right, let's go back. We can reduce out the C's to 1 over 1, the D's to 1 over 1, and the H's to 1 over 1. So now I have 2DH plus 2CH equals CD. Don't forget, I'm trying to solve for C. Now, my new equation, I've gotten rid of the fractions. That's good. There are 3 terms. 2 of the terms contain the variable C, and 1 of the terms does not. Let's get all the terms with the variable C on one side of the equation. I'm going to go ahead and put it on the right. So I'm going to subtract 2CH from both sides. That's going to give me 2DH equals CD minus 2CH. Now, CD minus 2CH, those are not like terms, so I can't put them together, but they both contain C. Now, it's this next step that's a big step. You see this a lot in math. How many of you are planning on going on like to calculus? Any of you? Okay, how about or pre-calc, math 141? Or trig, anything? Okay, well, who knows? All right, you'll see this a lot in the future is what I was getting at. Here's what we're gonna do. We're gonna factor the C out of the 2 terms. See what I did there?
Yes.
Now, I'm going to divide both sides by D minus 2H, and voila. C equals 2DH over D minus 2h. Kind of messy, but I've solved for c. So what did I do? First, I cleared all the fractions. Then I collected all the terms with c on one side of the equation, all the terms without c on the other side of the equation. Then I factored out the c so that I could then divide both sides by what was left over, that d minus 2h. Any questions on this problem?
No.
All right. Let's see here. Here's another problem that says solve for c, but it's different. So PC over S equals T over R. And we are to solve for C. All right. We could do this in 2 steps, or we can do it in 1 step. I'm going to do it in 1 step first, and then if I lose you, I'll go back and do it in 2 steps. But let's look at something else for a minute. What if I had 2/3 C equals 14 ninths? Okay. What do you do when you're trying to solve for a variable and you want to get rid of the coefficient, and the coefficient is a fraction? Do you remember what you do? I'll take that as a no. You multiply both sides by the reciprocal. So the 3's go, the 2's go, and then you continue on. Do you remember doing that?
Yes.
Okay, and then this reduces to 1/3 and 7/2, and we get 7/6. But okay, so PC over S. Recall that all of these variables represent numbers. So if C is our variable of interest, what is the coefficient of C? Wouldn't it be P over S?
Yes.
And isn't P over S a fraction?
So you would multiply it by the reciprocal,
Which would be,
S over P.
bingo. So P's go, S's go, C is left. And let's see, I'm going to put these in alphabetical order. So I'm going to go ST over PR. And it doesn't really matter if I did that or not, but okay. Now, I'm going to go back and do the same problem and do it in 2 steps just to show you that, yeah, you don't have to do it in just 1 step. But if you can see that, why not? So here's the 2-step method. So let's see if we have a, what was it here? PC over S equals T over R. So we'd clear the fraction, which would be, I suppose we could multiply both sides by SR. Okay, so we'd have SR and SR. So that's going to give me that and that. So I'm going to get PCR equals TS. And then I'm going to divide both sides by PR. So C equals ST over PR. So you can do it that way. Just takes 2 steps instead of 1. But if you can look at this and say, oh, well, PS is the coefficient of C, so to speak, multiply by its reciprocal, and you're there. All righty. Okay, let's see here. Oh, I know what I need to do. Yeah, okay. A divided by 3 plus 3 divided by 5 plus A divided by 15. A divided by 3 plus 3 divided by 5 equals A divided by 15. Okay. Can you tell me what this is? Listen very closely. Can you hear it?
Yes.
Really? What is it?
I can't hear it. I don't, what are we listening for?
It's the sound of one hand clapping.
Okay.
Oh, I thought you were referring to like, can you hear me? Because you were gonna say what it was.
What's this?
Clapping.
Ah, there's two hands now, right? So this, if there's not another hand over there, you really don't. I mean, I've seen people that can clap their hand by wrapping around, but what does that have to do with anything? Well, looking at the two things that I wrote, the one on the left side is kind of like this. The one on the right side is kind of like that. Does anybody see what I'm trying to get at? What's the difference between the left side and the right side?
The right side is equal to something, whereas the first one doesn't have anything equal to.
Right, correct. The right side is an equation. We can solve an equation by multiplying both sides by the LCD. The left side is not an equation. We can't multiply both sides because we don't have both sides. So the left side, what we have to do, we're just adding like terms. We can't multiply by 15 and clear the fractions because you only got one side. You have to be able to multiply both sides of an equation. It's not an equation. So the left side, the LCD is 15. So basically, you're going to build everything up. This goes back to the beginning of the chapter where we added and subtracted fractions, okay, before we got to the equations. So let's see here. I need a 5 over a 5 for a 5a. I need a 3 over a 3 for a 9. And the second one is okay, so I have an a there. All right, careful my a's and my 9s. The one in the middle there, that's a 9. So what have I got? I've got 6a plus 9 over 15. Okay. Can I do anything else with that fraction?
You can take out a 3 in the numerator.
Correct. I can take out a 3 and I get a 2a plus 3 and a 3 times 5. So I get 2a plus 3 over 5. So all I've done is I've simplified that expression. I did not solve it. I didn't determine what a was, okay? Because it's not an equation. Now, on the right side, that is an equation. What's the LCD?
15.
Same thing, right? But now I'm going to multiply both sides of an equation. So I get 15 times a over 3 plus 15 times 3 over 5 equals 9/15 times 15 over 1. 15 over 3 is 5 over 1. 15 over 5 is 3 over 1. 15 over 15 is 1 over 1. So I've got 5a plus 9 equals, let's see, is that an a? Yeah. Hang on here. That looked like a 9, but that's actually an a. So what do I have here? Just a, right? Why do they put 9s and a's in the same problem? It's just not fair. Or 5s and s's. Okay, I'm going to subtract a from both sides. 4a plus 9 equals 0. Subtract 9 from both sides. 4a equals -9. Divide by 4. A equals -9/4. Look at my original equation. There's no variables in the denominator, So there's no way that a value of A is going to make it undefined, because you can't plug A into a denominator if there's no A in a denominator, kind of thing. Okay, but first one was an expression. We build, combine like terms, simplify. Second one was an equation that we can multiply both sides by to clear out the fractions. All righty, so make sure you distinguish between the two of them. And with that, I bid you adieu. Have a great weekend. I'll be back at 1:15 if you have any questions. I'm going to go ahead and stop the recording.